Okay, so you're buying your first house for $220,000 and you're paying $30,000 as a down payment. So what are you really borrowing here? You're going to borrow 220,000 minus 30,000. And so you're really borrowing 190,000, so that's kind of key. And you arranged, well, then they told us to finance the remaining $190,000 30-year mortgage with a 7% nominal interest rate and monthly payments. What are the equal monthly payments you must make? Now, this one's tricky because it has monthly payments, so that means monthly compounding. So, my future value is that I'll pay everything off. If it's let's see, it's a 30-year mortgage, but I'll have to multiply it times 12 to get the number of compounding periods. So 30 times 12. I'll have 360 months that I'll be paying. And the interest rate is going to be 7%. And I have to divide that by 12 because we have to make it a monthly rate. So I'll put 7 divided by 12 is equal to 0.5833. And then, let's see, I'm solving for payment, so I'll put payment. That's the ultimate thing I want to find. And then the present value is the amount that I borrow. So I borrow 190,000. Okay. So now I can go in and put 0 in for future value, 360 for in, and 0.5833 as I. And you just enter it in as a decimal if that's what you get when you divide it. And then 190,000 as my present value because I'm borrowing that amount. And then I hit compute payment, and my monthly payment should be 1264.02. So 1264, well, they just rounded it. So 1264. Answer C for that one. So the next one, Jill currently has $300,000 in a brokerage account that pays 10% interest. And assume that she makes no additional contributions to the account. How many years will it take for her to have $1 million in the account? So how many years? That's saying N is equal to what? So right now she has a present value of $300,000 in her account. And she's lucky because she's earning 10% interest. She makes no other contributions, so the payment is 0. And the future value, she wants it to be $1 million. So N is equal to, and let's go over here to the calculator. So 300,000 is the present value. 10 is the interest rate. 0 payment. And 1 million is the desired future value. And actually, so let me show you what will happen if I hit second, or if I hit compute in. I'll get an error message, and that's because I did not put one of these values as a negative. So I need to put $300,000 as a negative. So I can easily go back and put that as a negative and put it in the present value because the calculator can't compute it that way. So it's like she made a $300,000 investment to ultimately get $1 million in the future. And then now I can hit compute in, and it takes 12.63 years. So we've got answer E. So anyways, that's a good illustration of if you get the error, you know that you should put one of these values as a negative, and we usually kind of choose the present value. Okay, so now let's go back down to where we were. Question 14, or I'm sorry, question 11. Okay, you can buy a perpetuity that pays $1,000 annually, and your required rate of return on this investment is 15%. You should be indifferent to buying or not buying the investment if it were offered at a price of what? So this is solving for the price or the present value of a perpetuity, and it's just the payment divided by the discount rate. Same thing as the payment divided by R. And so I've got to just go over here and hit 1,000 divided by 0.15, and I get the price is equal to $6,666.67. So answer C. And let's look at number 12. This is involving a company's 2005 sales, or 100 million. If sales grow at 8% per year, how large will they be 10 years later in 2015? So right now, the present value is that their sales are 100 million. It says the interest rate, or the rate they're growing, is 8% per year. And how large will it be 10 years from now? So n is equal to 10. And so we don't have a payment here, and we're solving for the future value. Yeah, so we would go over here and put in 100 present value, 8I, 10 n, 0 payment, and hit compute future value. And so the sales should be 215.89 million. And so that's answer E. Okay, we're almost done here. So suppose a U.S. government bond will pay $1,000 3 years from now. So I know that's a future value. If the going interest rate on 3-year government bonds is 4%, that's I, how much is the bond worth today? So I know the future value is 1,000. It's 3 years in terms of it's a 3-year bond. The interest rate is 4, and we want to know the present value. And we don't need the payment because they didn't say there were any payments. So I'll go to 1,000 and hit future value. 3 and n, 4 in the interest rate, 0 in payment, and then hit compute present value. And then I get $888.99, which is really, I'm sorry, yeah, 808, which is the same thing as 889, because that's what they wrote for answer C. And, oh, okay, well, we still have 2 more. Okay, well, it's good to have a lot of examples for this chapter. So your father is about to retire, and he wants to buy an annuity that will provide him with $50,000 of income per year for 20 years, beginning a year from today. So that means we keep our calculator in N mode because it's a year from today. The going rate on such annuities is 6%. How much would it cost him to buy this annuity today? So that means we want to know the price. We write down N, future value, the interest rate, and the payment. So let's see, what do we have? He wants $50,000 of income per year. So he wants $50,000 here for payment for 20 years, so N is 20, beginning a year from today, and the interest rate is 6%. How much would it cost him? And so he doesn't have a future value, so we'll put that as 0. So in the calculator, I'll put 20 and N, 0 for future value, 6 for the interest rate, and 50,000 for the payment, and compute the price. So it should cost him $573,000, 496.06. So that's answer E again. Oh, I'm sorry. Okay, let's see how many more there are. Okay, this really is the last two now. Okay, assume you own an annuity that will pay you $10,000 per year for 10 years. So we've got a payment of $10,000 for N equals 10 years. And the first payment is made today. So that's like big sign for that we need begin mode. And so I need to go to second payment, second enter, because that changes it. Now begin mode. And your girlfriend's father offers to give you $45,000 for the annuity. So that's like today, he'll give you $45,000 to get this $10,000 annuity. So let's just go ahead and put this as negative 45,000. And then we've got I, and we've got future value left. If you sell it, what rate of return would your girlfriend's father earn on his investment? And so the future value will be 0. There'll be nothing left. So let me go to 10,000 and hit payment. 10 N that's the number of years. 45,000 negative present value, a 0 for the future value, and then hit compute I. So 24.63%. And that one is answer D. Okay, so let's look at the last question, number 16. So you own an oil well that will pay you $25,000 per year for 8 years, with the first payment being made today. So that means we need begin mode. If you think a fair return on the well is 7%, how much should you ask if you decide to sell it? Okay, so it pays you $25,000 per year. So the payment is $25,000 for 8 years. And over here I can see that my calculator is in begin mode. If you think a fair return on the well is 7%, how much should you ask for if you sell it? That means what's the price or the present value? And so the future value is equal to 0. Okay, so let me go to 25,000 and hit payment. 8 is N, 7 is I, 0 is future value, and then hit compute present value. So 159,732.23, but it looks like they rounded. So answer A. So that would be a pretty good deal. And that was the end of these extra problems that we could work on for Chapter 5.